I wasn't recording that whole time. Those of you that are tuning in to find another embedded hacking kind of activity similar to the webcam, I do have one of those in the works. It's there's a teaser that I put out on the Discord server, and you can go check that out. Let me know what you think. I'm pretty excited about the project overall. Tracking activated. 8 years ago, I created a practical demo for explaining DevOps and trying to make the point that it's simpler than people make it out to be. Through the years, I've created several of these videos through job searches and also consulting activities, most of those covered by an NDA. This one is not. I'm gonna let you guys go through and pick it apart. So, you know, the thing is though, pay attention, because while the tools are different now, the conceptual process really hasn't changed. And if you're interested in seeing an updated video, since this is a little bit different than what I normally cover, let me know in the comments, and maybe I could even create a contrasting and better produced video. All right, so now if you're not aware, even still in 2024, many enterprises and governments are still leveraging VMware within the data center because the cost benefits of migrating to the cloud still just don't balance. However, you know, the tools definitely still have changed. So this is primarily using Subversion, Perl, and VMware. And you know, given what Broadcom's doing, I see that VMware is not going to be the incumbent much longer. Tools such as Perl for infrastructure automation definitely have been supplanted by Python. Where is it? It's over here, by Python. Controversial thing I like to say is that Python is the new Perl. Yes, new Perl. Okay, moving along. All right, interesting fact, the term DevOps was coined in 2009. So now, when I first heard about it, I've just said, it seems like this is the same thing I've been doing for the last 10 years. Also in 2009, that was the year that I traded in my BlackBerry for an iPhone 3GS. All right, of course, so this is me. So in the presentation, I have to demonstrate how a single individual can build everything from scratch in far less time than the average team claims that it takes. You take that for what you like, but that's generally a theme throughout my career, pushing back against the idea of over-specialization in systems and software engineering. All right, well, without further ado, feel free to have fun with listening to and hopefully learning a little bit about vanilla DevOps.
Vanilla DevOps, you ask? Well, see, the thing is that I'm a big fan of vanilla ice cream and its variants. The base, you know, the vanilla ice cream is a great foundational base for other kinds like chocolate chip cookie dough, cookies and cream, pralines and cream. You know, all of these different flavors of ice cream start out with a base. And I think it's important that when we talk about frameworks and you know, the DevOps process, that sometimes we come back and we think, okay, how can I solve this with the simplest tools at hand without having to necessarily learn a new framework? Now, this can be useful in several ways. Number one, from a learning curve perspective, also from a familiarity perspective. If you are a developer or an operations guy or a testing guy, you know, that's going into Agile and trying to develop DevOps for the first time, you may not want to immediately have to go out and learn a whole bunch of new tools. So one of the reasons that I did this was so that I could show a DevOps story of kind of continuous deployment with just using vanilla out of the box type tools. Now we are going to include a few things like Jenkins and others, But for the most part, we didn't use Razor, we didn't use Puppet, we didn't use Chef. And for the last year and a half, I've been dealing with the HP automation suite. And I had a real hunkering for wanting to go through and within a short time box, be able to demonstrate the kind of the out of the box tools that you might use in order to tell a DevOps story. And this can be a springboard for iterating the DevOps process, right? But it's something that everybody should be familiar with. Now, in our basic kind of workflow, right, the idea is that we want a couple different kinds of feedback patterns. Okay, the developer is going to write his code, he's going to commit it to a repository, and because we want consistency of builds and avoiding the classic, it doesn't work on my workstation, or it works on my workstation, don't know what your problem is. We want to, of course, have the build server. That's pretty much a given in today's development world. Now, while there are containers and other ways to do deployment, what we're going to be looking at is just a bare metal build. Okay, and this is partly for my own reasons, because I wanted to be able to do end-to-end automation of builds using ESXi, the free version of ESX that does not have vCenter. So we don't have vCenter in this environment. So we're gonna build the application, and then we're gonna kick off a provision of a new Linux box. In this case, could be modified for Windows, but we're going to take that new VM, we're going to publish our release to it, and then we're going to run. So we have our basic build provision run, and then in the case of a developer or a tester, right, they may want to either play around with the box for a little while to do QA testing, that sort of thing, or especially in the case of a periodic build from Jenkins, you just want to destroy it so that you don't consume all your resources. So we're going to build new each time we check in to Jenkins and have a release. In the operation standpoint, right, we want consistency of the builds. So from an operations standpoint, they could provision a new system. Again, we're using bare metal as an example, but they can provision a new system knowing that it has been built the same way with the same patterns through the development process. So you really have this holistic end-to-end consistency that goes from dev, test, and into operations. Obviously, the operations folks may not want to immediately destroy their production image they just deployed, so we'll let them keep it around. In this project, we did have to create a good collection of tools. Now, this is normally going to be about the topology that you're going to have in a traditional enterprise type environment. I happen to be using my own ESXi server, and so I already had all these available. It's on consumer grade hardware. I think we have, six cores, so we have a bunch of cores and 32 gig of RAM to support this infrastructure. We have two networks. Right, we have a provisioning network, and this is to kickstart the systems. And we have a general network, which is actually my home LAN, right? And that's where we are going to do the deployment, right? So this is kind of the production network. The provisioning network is a classic pattern used by service providers in order to provision new hosts. On that provisioning network, right, we have a provisioning server. So this is going to host our DHCP TFTP server for getting the Pixie boot configuration over to the host on first boot. We're going to host our CentOS 7 repository so that we can download all the packages. We also need our kickstart file, right? So that comes after the PXE. The kickstart is how we do automated Linux installs. And we're going to have to host a web server in order to do that. I'm not a huge fan of leveraging NFS in automated builds if I can, just because of some bad history that I had with locking and other kinds of issues. So we'll only be using HTTP for these automated builds. So moving along, we have the build and repository server. So this is your standard setup of, basic Jenkins, a Subversion repository. Sorry for you Git fans. I'm a fan of Git as well, but Subversion is very ingrained in enterprises and still, quite alive. So definitely you could be taking a Git repository and publishing it to Subversion, but for now, instead of using Git, we are using the classic Subversion pattern. In order to do all that, we, of course, host a HTTP server so that we can get to our SVN code and artifacts. And in this scenario, and we're introducing the automator here, we do have the SSH keys stored to be able to go from Jenkins to issue commands to the automator. And moving along, the automator is just a Linux host that's set up with the correct kind of permissions, right, to be able to talk to our ESX host, right? This is our hypervisor. Now, as an element manager, you could take this use case very quickly and move it to total bare metal, right? No VM. So I have a managed switch, and you could leverage VLANs. In fact, I actually have these on 2 different VLANs, even though we're doing everything on ESX. So you have VLANs and a PDU, right? So you have a networked PDU. And then so you could swap out this ESXi server if you wanted true bare metal provisioning, because you had databases and maybe some proprietary systems, proprietary peripherals that you need to be able to provision to. You can swap ESX out for a minimalistic controller, and so that would not be all that difficult. Switching VLANs, switch the device on and off, maybe an annex like a serial controller. So for about maybe another $1,000, you could swap this over into the realm of pure bare metal. Okay, continuing on with the automator here. The automator, all it does, this might be your Puppet Master or your Chef workstation, Chef server, depending on what you want to do. However, all we're doing is running our scripts, right? Some of our provisioning scripts, and that also includes the build, not the building and compiling. That's done on the Jenkins build server, but on the building of the, we're going to control the orchestration of the VM build and distributing out the package. It's also going to serve as an artifact cache. So if I'm an operator, right, and I want to provision a release, I can execute a command here from the automator and deploy a new system. Same goes with testing. This makes it definitely so that the developer doesn't have to spend time in helping the testing folks get everything configured and all that for their app, right? They can set this all up, run it. It's going to be consistent for the tester. The developer has to spend one session getting this all set up, and then it has a trickle downstream effect for ops and testing. Lastly, we're going to be talking to ESX, and we're going to be talking to the VM. So the SSH keys, that's how we're accomplishing this. SSH keys are baked in for the automator. So, and this is a standard pattern. Automator, right, he's going to have this kind of elevated privileges on the firewall on the network so that he can access these different systems. The build repo does not have access to ESX. Or to the VMs, really. The provisioning server does not have access to the repo, right? All that sort of thing. However, the provisioning server sits on 2 networks, right? So Automator and the repo server sit on the sit on the general LAN. You have the Jenkins, right, which is our build server, and the Automator sitting on the general LAN, and they're talking to the provisioning server that lives on both, and the ESX server, which is an element manager. Technically, it's on the general LAN, so it's kind of outside special case. All right, let's get into the demo. Let's start the story with the developer, and he's written a simple project. A simple Java application that's going to print out the string here, hello world, right? And let's just change that. Okay, so we've already checked it into Subversion because we've had a couple of revisions, and now we're pretty set on this build, so we're ready to go. So what we'll do now is go ahead and save it and move on into commit. Put in a good comment. Okay. So now we've checked our source code in, and we'll pull up our Jenkins. Now on our Jenkins project here, we have the Hello World project. And while we can pull and have an automatic pull or push and have an automatic build, in this case, we're probably just going to kick off a new build here. And let's tour real quick the configuration of this build or of this project. So going down, we have our Subversion repository, our polling stuff, and then in the build, we're just going to do a couple simple commands. We're going to compile the Java source code. We're going to package it up as a jar with the build number in Jenkins. And then we're going to do an SVN import. Now, what you should do in best practice is actually have two different projects, one that triggers the other, but for simplicity, I'm including them all in one project. But we're going to do an SVN import of that jar so that we have a artifact, and the operations folks are going to be the ones that are going to consume that long run, but we're also going to use it in our provisioning process. So lastly, what we're going to do is deploy that jar down to the Automator into the temp directory, and we're going to kick off our script for deploying. Now, in this case, you'll notice that I'm passing both the artifact that we're going to be running so that we can actually run it for testing purposes, and also that we're going to destroy it at the end. Now, since I already kicked off this build, we'll go into the console output, and starting at the beginning, what we're doing is following those steps, and then when we get to the first shell scripts here, we're going to kick off a Perl script, and that Perl script is going to start by creating this, creating a new system. We're using epoch time so that we have a unique identifier for the host, but as you can see, this just kicked off. And what it's doing is it's sitting on the provisioning network, and the provisioning network provided an IP address and gave it the kernel. In the Pixie configuration was so that it would boot into a bootstrap kernel, and then a kickstart file was given as an option in the boot menu. Okay, and we defaulted to CentOS 7. I have a couple other things that can be provisioned from here, but what we have the timeout for is CentOS 7. So while that's proceeding, we can take a look at the actual script. Now, I have debug on the script right now, but what you can see is these debug statements that are creating the system, actually using the VMDK or the VMK FS tools to create the data store, right? And we then power it on so that we get the generated MAC address, and that's part of the process for Pixie booting. Now what we're going to be doing is we're just sitting here and waiting for it to get an actual IP. So let's move on to the script. This script is sitting on the Automator host, and it's just a simple put together Perl script. I had to decide which language I wanted to use, and I haven't used Perl in a while. It is one of my main languages that I started with, and I could have chosen a lot of different languages, but I prefer Perl for demonstration, and it was quick at hand. I haven't written a whole lot of scripts in the last few months, and so, or at least not anything that was major, so I pick the closest at hand, and hopefully it's pretty understandable. So number one, we've got the debug on. We're going to get a few of the arguments, right? So the first argument is the artifact that we're going to be deploying to the system. We're going to decide whether we want to keep the build or not. Now, there's in future iterations, right, there's definitely more error handling that I can do in this script, and using operations or parameter type constraints. But this has been all completed within a 2-day time frame. So we went through it pretty quick, and the idea is to improve it on future iterations. So in here, we've kind of broken up into sections. The first section is going to be where we're just setting up, generating the name, setting the data store, all of those sort of things. The VMX template is actually contained within here, and obviously that could be decoupled, but for now what we have is a multi-line string that we're going to write out to ESX. We have the path, and these are, again, hard-coded, but could be turned into options. Okay, now we're going to start getting into the interesting part, which is to create the VM. Now, you'll notice in here that we have a lot of subroutines. And what I like to do is try and be as functional as possible, right? And almost create DSLs, whether I'm doing it in Python, Perl, Java, right, or JavaScript, right? I want to use as many functions as possible so that I can start to kind of write in a language. When I very first started out, I was primarily doing C, Perl, and Lisp, working with the military, and so I learned how to create DSLs very quickly to help save myself time. So in this case, we did recreate a little bit of a wheel, but I didn't have to import any libraries. This is all just vanilla install Perl 5, whatever's on here. And so we'll get to look at the functions here in a second, but we're going to go ahead and go through the process, which is relatively simple, of creating the what ESX needs, right, in order to provision the system. And what we'll do is we have to get the VM ID, so that we can hold on to that later on. We need to get the MAC address. The MAC address isn't generated until the first boot, so we're going to go ahead and power it on. When we power it on, it's going to start provisioning, and we're going to go through and get the MAC address so that we can have that for the DHCP server. We don't actually do anything with it right now, because we're not making entries into the DHCP server, but for changing, providing options for different operating systems like Windows or different version of CentOS, right, we would need to be able to have that. For time considerations, I skipped that portion. Okay, so for the PXE boot side, right, what we're doing is here we're waiting for a valid IP. Now, in the Kickstart file, we included the Open VM Tools package. So when this system boots up for the first time and is fully provisioned on the provisioning network, we should see an IP address. And looks like we're already finished. Okay, so on these, what happened, and we're going to run through it real quick, but we provisioned on the provisioning network, we shut down the machine, we swap and we change the network, and then boot it back up and wait for another IP. So we're in the script, we're waiting for the IP, and then we're going to, once we see it on the, essentially on the 72 network, right? We're going to issue an appropriate power down and then move it. So that's all in the change VM network process. And we're just passing the provisioning LAN and the general LAN. So this could be configured pretty easily. And then we're going to wait for it to come back up. I have a standard DHCP server on my home LAN and on what we're calling the general LAN. And then we're good. Okay, well, what we have to do is now deploy this software, right? So we did pass in the artifact as a parameter, but that has a prerequisite, which is that we have Java on the machine. So we're going to go ahead and issue a remote host command, and that's actually executing on the new host because we have the IP address and the SSH keys are already there. So we're going to go ahead and yum install Java. We're going to SCP the build artifact on an automator command, and then we're going to run the actual artifact. Again, this could be scripted differently or a little bit more decoupled, but I wanted to have a straightforward example. So in our ending console output in Jenkins, what we should see is that original. If we go back over here to our IDE, we should see this dash demo, right? And it should have whatever the build number is. Okay, and then if you recall, we did want to go ahead and destroy the VM after it was complete. So if we pass destroy, then we're going to go ahead and destroy it. Okay, so that's finished. That's the main. Hopefully that was fairly understandable, fairly straightforward, right? We're building, deploying, and then deleting. Here in the functions section, and I didn't really do anything as an anonymous function, right? Where we pass a parameter, I can have an anonymous function. We try to keep these things fairly simple so that you could have a rather junior systems engineer or developer be able to digest this script and understand it. Okay, so always do a debug type statement or function. And the convenient thing, the reason why I'm able to move so quickly on these kinds of scripts is because we use these subroutines, which have most of the things similar in them, right? So we want to try and reuse. So the remote host command, the automator command, and the ESX command are fairly similar. However, right, they've got to vary just a little bit depending on where I'm running them. So as we go down, you see I stubbed out something that I didn't end up using. But for write the VMX file, right, what we did was SCP it over. So we kind of cheated a little bit there, didn't reuse much. But there you go. So we SCP'd that VMX file over, where now we're getting into kind of the utility functions, right? And I just created them as I needed them. So I can check EXX to see whether it's responding or not, right? That's kind of a first check if you're going to have a failure. And then here's where we get to reuse the ESX command, right? I get to power on, shut down. Shutdown's the graceful version of off. Off is when we do destroy, because we don't really care about the operating system anymore if we just want to destroy. And then the destroy command is called. So when we do destroy, we actually reuse the ESX command, right? Going down, we have the getting the MAC address, right? Power reset, get the VM IP, right? So these are some of our getters, using some regular expressions there. Now, when we get into wait for VM IP, right? That's when we switch networks, or we're in the dark side of the moon scenario, so we wait for it to come up the first time. We're going to wait for that IP. And this isn't the best error handling here, but if it's unset, we're going to loop. And if the IP gets in there, right, we're gonna exit out. We do take the cost of the extra sleep time at the end of the loop, and we return the IP. So when we're creating functions, right, we want to have some consistent parameterization and consistent returns always, right? So that I kind of have a standard look and feel to when I'm writing in the main, because the main idea of scripts is that, and doing functional programming is that I'm going to let myself, I'm going to make it easier on myself in the long term in order to reuse what I've done before, right, without having to relearn it. Or in the case of passing code along, I want to divide it out so that someone else can understand it and reuse it and get up and running pretty quickly. Okay, so we'll just kind of go through some of the rest of the functions here. This is the change network. And we're also leveraging, we're reusing a couple different functions there. Okay, well that's it. It's pretty easy. We're just reusing, we're just really using SSH and CLI here instead of having to use web services or vCenter. It's not that those don't have a good place. It's just I like to be able to demonstrate the simplest form or the most direct form of accomplishing a project or accomplishing a task sometimes. It helps for demonstration. I'm going to move out of here. And while we have already removed our entry on our build, we're going to go ahead and go back to the build. And what you can see is we got our final IP address, right? We went through the process of deploying the package, of installing Yum, and then running the actual application, and there we go. So we have our Hello World demo. Now, this is off of 130. Sorry for the cut there, had an interruption. But we're running off of build 130. And you can see in the Subversion repository, right, we have our 130 build. Now, what I'm going to do is go on over into the Automator, and we're going to run this from the command line. So let's imagine that I am the operations person, right, in this scenario, and or the testing person, and I want to be able to deploy without losing it, right? Or I'm doing a one-off because the developer just told me that he released some new things, and I need to have my own VM for a little while, and I need to do something with it. So I think it was 130 was the build. Now, what we could do is in here, my quote-unquote cache is just in temp, right? So I have those jars there. So let's go in and go to build 130. And if you kind of keep an eye over here on ESX, we'll be able to see it build. Okay, so you saw that we just built up the machine and it came up. Now let me here, let's do the summary and let's bring up the console and watch it build. Okay, so we've got our boot screen for Pixie. You'll note that it's on the provisioning network. Okay, well, we can see that we have booted our DevOps box. Now we're just waiting for our IP to register the VMware tools. With our .72.240 address, we'll wait now for the IP address here. Goes from unset to our 240 IP address. And we'll have to take the hit of the wait time at the end of that while loop. All right, now we are going into the process of shutting down the machine and moving it to the new network. And then we'll wait again for it to power up with our final IP address. We now have our new .50 IP address here on the general LAN. And you can see that this is switched. As soon as that hits, here we go. We're going to see some of the standard out from Yum. Now, this is primarily going to be some of the standard, the warnings, right? So I'm not capturing all of the standard error, standard out as it is using the cursus library, right, to go across the screen. But you'll see the Yum install complete, and then we'll deploy our package, and we'll be good to go. We'll see the final test run of running the application, and then the VM is ours to do what we want with. And there you have it, completely hands off. The only command that we issued was our provision script. And we have our hello world demo. And if I was to go here into the new box, which looks like is 189, SSH root at, right? What we have is in the temp directory, we have that hello world.130. All right, let's give it to the recap. I was able to cover, I think, most of the points here in my presentation storyboard. So let's zoom in and do the quick wrap up. So let's take this from the perspective of fast, cheap, good for this solution, right? Obviously, it was fast. Not only was I able to do a bare metal build in 10 minutes, but I was able to get all this stood up and written, the automations with not a lot of extra prerequisites, right? No frameworks in the back end helping me out. So we were able to do this in about 16 hours, right? About 2 days. So I would say yes, it's fast. We did this from scratch with ESX in 16 hours. Now that doesn't include the downloading of the ISOs, right? But assuming I already had the ISOs, that would have taken about 16 hours or so. So cheap? Well, yes. So we're talking about consumer grade hardware. and we're talking about free and open tools. So ESXi is free and is common in the enterprise, but vCenter is expensive. And while it's common in the enterprise, not everybody always has access to it in their lab the way they would like. Access to the API. A lot of times they have to go to their ESX administrator, even in the lab, right? So what this enables a small group to do, let's say they're going agile, is either have an ESX server assigned to them in the lab. Maybe they even set it up in the bullpen, right? And then deal with the networking. Again, all of this networking is self-contained. Now, if you wanted to sprawl this out, again, you could, for fairly inexpensive, add a couple pieces of hardware and swap out ESX, right? So we also don't have to worry about paying any licensing fees, because we're doing a trial or something like that, right? So obviously for enterprise support, that's those models, right? So that's what you would want to go with. But all of these tools were also common in an enterprise or a small business. Good? Well, it definitely does not follow the best practices that I would say for production. Definitely, you could use this for a small team in an organization for a nice, quick, agile DevOps type process. But between the lack of error handling, the happy path that I've taken in my scripts, and the there's a lot of other kind of scaling gaps, right? As far as multi-user, auditing, all of those sort of things, but it's a good starting point is what it is. Now, I could imagine a small group taking something like this and using it in their iteration 0, which in Agile, I like to have an iteration 0 where you're kind of doing quick prototyping while the Scrum Master is still figuring out some of the stories and you guys are doing voting and all that, right? You're trying to figure out what's going to be difficult. You're setting up your environment. This is something that can be set up in about 2 days by one individual, right? And get it up and running. And then you can add in all the other kind of things like Sonar and, if you want to not use Subversion, instead you wanted to use Git, you could decide on different technologies as for automation or packaging, right? But this is just what you can start using as a baseline. Okay, so that is my demo. And we're just going to have to say thank you and talk to you soon. I hope you liked it, and I welcome any suggestions or feedback.